Hi, in this video I'm going to talk about residual analysis in simple linear regression. This is chapter 14, and what we are doing here is we're checking some assumptions of regression analysis. Remember that we're trying to estimate the relationship between two variables. Let me show you so you can understand. Remember this case, that's the restaurant, the Armand's Pizza Parlor, and then we have certain number of students in campuses around restaurants and the sales, and we're trying to establish the relationship between what is the impact of student population on sales. And each one of these dots is the actual data, and in this line here is our model. So we are trying to predict how much, let's say, this restaurant's gonna sell based on the number of students, and then we have a different actual value. Okay, so this is what's gonna happen in reality, and this is what our model is predicting. So we see that there is a difference. This difference is the error. Okay, so this is known as error. So regression analysis uses data to estimate the relationship between a dependent variable and independent variables. In this case, is only one independent variable. A residual is the difference between what we observed and whatever we fitted using the regression. This is what I showed you in the Excel file here. So this is what really happened, and this is what our model is predicting based on the student population and B0 and B1, this model right here. Okay, so I'm going to show you that happening. I just want to keep talking about residual analysis. So residual and error is like similar terms for the same concept, the difference between what we observed and what our model predicted. This is the error, this is the residual, the difference. Okay, this is what I'm talking about in this slide. Residual is the same as error, is how much mistake we commit in trying to predict an observed value using the regression model. That's another understanding. So what are the assumptions about the residual or the error terms? The error term is the Greek letter eta. I think that's eta in our regression equation. Okay, so the model assumptions are: the error term is a random variable with mean of 0. The variance of the error, denoted by variance, the sigma squared, is the same for all values of the independent variable. So regardless of the value of the independent variable, regardless of how much the student population is, the variance of residuals are always the same. This is what this is saying. The values of the error term are independent, and the error term is a normally distributed random variable. So we're going to check most of these assumptions and see if our model matches and attains these assumptions. That's very important in regression analysis. Otherwise, the results of a regression analysis are not good. So if the assumptions about the error term appear questionable, the hypothesis test about the significance of the relationship may not be valid. So this is what the problem is. If these assumptions don't hold, then our results may not be valid. So the residuals provide the best information about the error term. Okay, and the residual for each observation is the actual data minus the predicted value. So let's take a look at that to make it more meaningful to you. Okay, so this is our regression analysis. So let's predict how. This is just for you to see what the error is. You don't really need to do that in the problems, but it's for your understanding. So I want to predict how much the sales will be using this formula here. Okay, so the formula says that the prediction y is equal to 5 times x, 5 times the student population plus 60. Let's do this. So it's equal to, open parentheses, 5 times student population plus 60. Okay, so the prediction in our model using this formula 70, you see that is a little above the 50 or the 58 that we observe here. Okay, so we can do that for all observations. Okay, so for example, here we can see that our model predicts the 10th restaurant, which has a sales of 202. I'm sorry, which has a population of 26 as population. It predicts to be 190, which is below what we observed here in this blue dot as 202. Okay, so you see that this is what our model is predicting. This is what this linear line is. Okay, now let's see the error or residual. It's the same thing. What is the residual? This slide is saying that the residual is what we observed minus the prediction. Y hat is the prediction. Y hat. Okay, so let's compute what we observed, the sales, minus the prediction. So the error is -12. And if we do that to all them, we have all the errors in our model. Okay, if you select all them, you see that they sum to 0 right here. Okay, so -12 is this difference here. Okay, what we observed, 50 minus the prediction, 70. This difference here is 12. This difference here, which is seems to be the biggest, is the restaurant that has 22 as the population. So let's take a look. 22. Yes, that's the biggest residual, -21. So we observed 22 149 as sales. Okay, and our model predicted 170. So there is an error. There is a residual of -22, which is the difference. Okay, so this is what residuals are. Okay, so let me go to our book to show you. Here is chapter 14, and then under exploring statistics, I scroll down and I have diagnostic residual plots for the same Armand's Pizza Parlor, and then this one shows us the same chart that I have. It's a little like squeezed, like it's not too wide like in my Excel, but that's the same thing. So let's take a look here. This one, okay, this one is you see that when I go over that, that's the restaurant that has 22,000 and student population, and we can see that highlights here 21 as -21. You see here -21. So it's this residual. The student population is 22,000, and if we move over until here, you see that's -21. That's the same thing we have here, -21. So this like chart is showing the size of the residuals in a chart. This sheet is showing the residuals in numbers, and this is plotting these numbers so you can visually see which one is the biggest residual. You see that we have 3 restaurants here that have very low residual. The residual is negative something, negative maybe 2 or 3. I don't know, because the scale of this chart. Let's take a look at my, those are these 3 restaurants, -3, this, and this. So you see that they're very close to the prediction, which means their residuals are very, very low. So we have residuals, positive residuals above the 0 here are positive residuals, and below that is negative residuals. So negative residuals means that our model is predicting more than what we observed. Positive residuals means that our model is predicting less than what we observed. Okay, so here is a positive. Our model is predicting less than what happened. Okay, so this is the concept of residual, what a residual is, and we're gonna have one residual for each one of the observations, the restaurants, and we're going to test these assumptions to see if they hold, and I'm gonna show you all this in the next videos.